We are going to discuss double pendulum. My name is Dong Boxiang, with teammates 曾访景演和陈佑. As the name double pendulum suggests, the problem is about the trace of two pendulums attached with each other. We will represent the angles of the pendulum as θ1 and θ2, and the length of the two rods as L1 and L2. Since L1 and L2 are constant, and the pivot is fixed, the position of the two pendulums are determined by two angles θ1 and θ2. So in the following, we will try to find the differential equations of θ1 and θ2 with respect to time. First, we should transform the Cartesian coordinates to θ1 and θ2. Then we can represent the potential energy by θ1 and θ2. And also the kinetic energy. To simplify the question, we are going to apply the Lagrange equation, which can be derived from Newton's second law. Fi equals to m multiple xi double prime equals to the derivative of mxi prime with respect to time, and mxi prime equals to the derivative of half mxi prime squared with respect to xi prime, and the half mxi prime squared is just kinetic energy. Also, for conservative force F, Fi equals to minus derivative of potential energy with respect to xi. Since kinetic energy is independent from position, potential energy is independent from velocity. The derivative of kinetic energy with respect to xi equals to 0, and the derivative of potential energy with respect to xi prime also equals to 0. So we can let Lagrangian equals to kinetic energy minus potential energy. Then the Lagrange equation holds, because the equation will eventually become Fi minus Fi, which is just 0. Back to the double pendulum problem. Now we can derive the Lagrangian kinetic energy minus potential energy, which we have calculated earlier. Then we calculate the derivative of Lagrangian with respect to θ1, θ2, θ1 prime, and θ2 prime. Reminded that the Lagrangian is now a function of these four independent variables. Since there are two variables, θ1 and θ2, two Lagrange equations can be obtained. Plugging the derivative of the Lagrangian we have calculated earlier. Then simplify them. We finally get these two differential equations. However, for the convenience to simulate it in MATLAB, we need to make both θ1 double prime, θ2 double prime equals to functions of θ1, θ2, θ1 prime, and θ2 prime. So we change it into this form.